Alright, Advent of Code Day 5. Let's test the audio as usual. Day 5. Alright, audio seems fine. Alright, a bit of a chill one. CD 05. Let's create a little main. Like so. 05 GHC this. Alright, seems to work. Advent of Code Day 5. Satisfied with their search on series, the squadron of scholars Oops, I need to drink some water, I think. Suggests subsequently scanning the stationary stacks of Subbasement 17, the North Pole printing department is busier than ever this close to Christmas, and while the historians continue their search of this historically significant facility, an elf operating a very familiar printer beckons you over. The elf must recognize you because they waste no time explaining that the new Slate launch safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed, so you offer your services. Safety protocols clearly indicate that new pages for the safety manual must be printed in a very specific order. The notation X or Y means that if both page number X and page number Y are to be produced as part of an update, the page number X must be printed at some point before the page number Y. The elf has for you both the page ordering rules and the pages to produce in each update. Your puzzle input, you can't figure out whether each update has the pages in the right order. For example, this. So I have the page ordering rule and the pages to produce in each update. So there is a bunch of numbers that come after each other, and then other numbers. The first section specifies the page ordering rules, one per line. The first rule, 4753, means that an update includes both page number 47 and page 53, then page number 47 must be printed at some point before page number 43. 47 doesn't necessarily need to be immediately before 53. Oh, this is gonna be hard. Other pages are allowed to be between them. The second section specifies the page numbers of each update because most safety manuals are different. The pages needed in the updates are different to the first update. Oh, okay, I just need to check if those are... hello there, Alan. I just need to check... okay, no, it's gonna be okay, I think. I just need to check that each line respects the rules, I think. Other pages are allowed to be between them. The second section specifies the page number in each update because most safety manuals are different. The pages needed in an update are different too. The first update, this means that the update consists of page those numbers. To get the printer going as soon as possible, start by identifying which updates are already in the right order. Okay. In the above example, the first update, this is the right order correctly because because the first update does not include some pages numbers, ordering rule involved. Those missing pages numbers are ignored. The second and third update are also in the correct order. It's not in the correct order. In the correct order, breaking several rules. Okay, and at the end I get all the correct one, I print the middle one, and then I add those together. Okay. Let's first try to parse it. This is it. X clip example 1. So let's do the usual. I'm also started. This one is so messy. Oh no. Well, I don't have much time today, so I don't know if I will finish it, but I will try. Example 1. Print content. Yeah. Alright, that's fine. Then let's say I guess I'm gonna need each line. It would be so nice to have a split function right now, Haskell, but unfortunately they don't. Let's just say let else is equal to lines, content, like so. Now it's good. And so I'm gonna need to put the rules in some kind of thing. Can I do what was the span thing? Not spawn, span. So I think if I do let rules, no, I don't need a second let. I can just rules updates is equal to span span, and it's going to be equal to empty, so it's separated by an empty lines, an empty line else, and I say, let's say rules, no, that doesn't work, updates, fuck. What is the span again? Span applies a predicate to P and a list of X's returns a tuple where the first element... oh, yeah, it's not that. Break. Break applies a predicate P where the first element... split at. Well, split at would be nice as well. Okay, it's not span. Take while. Well, I could use take while or and drop while, but that sounds a bit... Haskell split list. No split function in Haskell is wild. Well, there is, yeah, kind of split-like function, but then there is the library, of course, that does this, but I don't want to install a library. But at some point I will need to, because this is quite annoying. Or I could copy-paste my own split function that I made at some point, but... I think for now, I could actually use the span function. I just have to be like, to do like, is this character lm of this? Well, I could just do lm like so. I think that could work. And so rules will be this, that makes sense. And this, we can ignore the first. So updates is not gonna include the empty one. Yeah, that works. So okay, that's a bit better. Now it's gonna be fun to split those. I guess I can just replace them by spaces and then do that. Can I do... so let's print the rules again. Can I convert this to a list of tuples? I think that would be nice. Can I say rules Can I reassign like this? No, I cannot. Rules, let's say 1, rules 2, this. Yeah, I'm sorry for the bad naming, but I'm a bit tired. How? So I should do like map something on rules 1. Next, I can just Haskell replace character in string. Replace, that's a function. That's okay. No, 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 no. That's on text. That's not on string. Yeah, and they just rewrite their own function. And I assume text replace is just, well, it's on text and it's also a package. Mm-hmm. And where is the split at thing? Split at returns a tuple where the first element of x is the prefix. Oh, well, but the real input is not like a fixed number. What do I do? Okay, I'm gonna really need the split package at some point, huh? This is quite annoying. Read file. Yeah, I will. How do I do this? Fuck. Yeah, okay. Fuck it. Let's just where's my freaking split function? I am too tired for this shit. There we go. Split in Haskell. Copy paste. There we go. Wow. Let's put that at the bottom. Pretend it's in the standard library as it should. So can I just map split on split on this? No, this. Okay, yeah, that's what I want, kind of. Except I need to make this into a tuple. Or do I need to? I don't know. Can I then like how do I convert this in a tuple for day 1 again? Yeah, I don't remember. I'm just gonna do a map like so, and this is gonna be x1, x2, and then something, and this is gonna return x1, x2. The parenthesis. Parse input. I need the parenthesis here as well, I think. Alright, I have my list of tuples. And I also need to read this, read this, like so. Let's put this here, except I have to do the special Haskell thing. Language type something, I forgot what it is. Type applications. Can I do this now? Can't apply expression of type this to this. What did I do here? Oh, right. So it's x1 like so, x2 like so. Alright, finally have what I want. Here I can do the same thing, updates 1, updates 2, and this is gonna be map splits on the comma this time, on updates 1, updates 2, like so, and then I would like to can I combine that with a map map read? Does that work? No, it does not. I guess I can do the same thing where I do map read on do map. Well, this is not pretty. I'm sure there is a better way, but I can do map read. And again, I can do the int thing. Alright, okay, I have what I want now. I have my rules and my update. Now, let's have a function called validates rules, which takes the rules like so, and then takes the one update. So one update will just be a list of int, and it returns a boolean. Validates rules, rules like so, updates. I think, can I do this? Can I do this? That will be slightly prettier. Up, like so. That's, yeah, it's slightly more Haskell naming, I guess. Now. What do I do now? I need to go over every single rules. So already I think I can do this. And if this is empty, we return true. I think that makes sense. If there is no rules, anything goes. And now I just need to do just need to check that the update validates one rule. How do I do this? I need to check that I could get the index of both things. So is there an index of? Index of? Is there a search? Data list. Data list, searching. LM that returns a bool. Lookup is not really what I want. Find. Find not really either. Filter, partition. LM index. Yes, that's what I want. Index function returns the index of the first, and there is indices as well. So it takes an element and a list of elements and returns maybe an index. Okay. Can I do let I1 is gonna be lm index the first R in update. Then I2 is gonna be the second element of R. And actually I could just say xy like so. It's would probably better to call this low and high. So like the lower bound, higher bounds. Like this, in let's say false for now, just to check if it compiles. And this is in import data list lm index, like so. Right, oops. And we return I1. But now I have to do by the way, can you map a function on a tuple? Can I map, let's say, +1 on... Can I do this? No. Okay. I cannot do this. So this can... What are the rules? The first section specifies this, the second section specifies this. To get the printer going as soon as possible, yes, 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 yes. It's correct because there are rules that put each other page after it. So if I don't find the element in the update, I guess it's by default the rule has passed. Correctly first because there are rules that put each other page after it. Must be after according to this. Okay, sure. So if how do I do this? Can I do case on I1, I2 of if it's nothing something, then it's true. If it's like the opposite, the other way around, it's true as well. If it's just I1, just I2, I wonder if you can reassign like this. We can say I1 lower than I2, like so. Does that? It does compile. And next, I just literally need to where valid rule r is equal to all of this, like so. And I guess I can put this. This will be R. And I can just do I can do all valid rule on on rules. Okay. Can I now run this on validate rules for rules, and we pass the first element of updates. Okay. And so the first one, the first update is in the right order. The second and the third update are also in the correct order. Okay, so if I do this one, true, true, the fourth update is not in the correct order. Let's see. Please don't return true. False! Okay, that's good. Okay, so now, well, I can be decently confident that it works. So can I just filter validate rules on this? No, like so, updates. Okay, and at the end we indeed got only those three. That's good. That's really good. And then I need to add the middle numbers together. So we can do valid updates is equal to this. And next, so we can print a map. Is there a sum by? I mean, that's a bit pointless, I know, but sum by. Nope. Well, it will be a map then sum, whatever. We can just take an update and say u this length u, like so. Oops. On valid updates, like so. Index. Oh yeah, right. Divided by 2. Is that correct? Yeah, I'm getting. So no instance of fractional int. Haskell divide in. Oh yeah, right. I remember now. It's div. I think that's good. 61, 53. That's good. And then I sum those up. Let's do sum this. All right, it works. Let's try on the actual input. Okay. Inputs like so. This is this number. Yeah. That's the right answer. Okay. It wasn't that bad. That's nice. Part 2. While the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, use the page ordering rule to put the page number in the right order. For the above example, here are 3 incorrectly ordered updates and their correct ordering. This becomes this, so I flip this one. This guy gets flipped, becomes this. After taking only the incorrectly ordered updates and ordering up together, their middle page numbers are this, and this. Adding them together, find the updates which are not in the correct order. What do you get if you add up the middle page number after correctly ordering? Just those updates. Okay, so I think the stupidest solution that I can think of is taking all the permutations of this and taking the first permutation that validates the rule. Haskell permutations, please be built in. Fine. Oh, thank God. Okay. So, permutations. And so does this do what I want? So if I have I say import data list permutations like this, yeah, it does do what I want it to do. Can I so now instead of filter, I would like to like split the valid and invalid. How do I do this? It's not span, it's well, it's something near span, I think. So come on, load. So there is break, it's not break either. Lookup, zip, no. Isn't there a thing that like or kind of partitions? Oh, wait, it's partition. Partition. Partition function takes a predicate and a list and returns a pair of the list, which do and do not. Okay, perfect. So this will become partition, and this is in the prelude, I think. And so this will be the valid one, this will be the unvalid updates, like so. Let me make this slightly bigger. Okay, does this still work? Partition, oh yeah. Where does partition come from? Oh, it's also in data list, okay. Partition. Okay, so this is still the correct answer, so that probably means that I do in fact have the ones I want. And so my stupid way of doing this, let's first do this on example 1. Like so, and this is the correct, yeah, this is the correct example answer. Can I do, can I do, so, fixed, invalid. It's not invalid, it's invalid. Invalid. Fixed invalid is map permutations on invalid updates. So I have the permutations, then can I, so I will have a list of permutations. Can I take the first one that validates the thing? Is there like a take first? How do I do this? I could do filter and head, but and with lazy evaluation it wouldn't actually take the first, but yeah, let's just do that. So I have the permutations. So I say U, I take the permutations on U, then I filter with this, like so. So now I will have this, and then I take the head, this, like so. And this should be good, okay. And then I do the same thing, but on the fixed invalid. Is that it? 1, 2, 3. 1, 2, 3! Let's go! I'm a smart boy, but let's see if my permutation will like explode when I do this on the actual input. Yikes. Yikes, it does explode. Okay, so that will take forever. So that's not the correct way. So I need to be smart. Cannot brute force it. That's a shame. Can I take a long time? Can I take a long coffee break? How long are those? They're not that long as well, so I wonder why it's taking so long. So let's say this guy uh, using Python. Yeah, this split this then length. There's only 23 permutation of 23. Well, that's 23 factorial, no? Yeah, that's a lot, maybe. Fuck. Like GXCI. Import data list permutations of this thing. Yeah. I understand why it takes a while now. Alright, I just can't do that. I just can't do that. What do I do now? What do I do now? I need to probably modify this and say like what can I say? Say whenever a rule is invalid, we flip the numbers. Oh yeah, that's actually not that bad. Yeah. All right, let's try that. Let's say fix update, which will take. Well, it will be the same, I think, like this. Except it doesn't return this, it will return this. And if I do fix update up, I probably should just copy paste this and here replace validate rules by fix update and this fix. This will be different. Like it will be map. No, or it will be. I don't know actually. Probably some kind of fold, but I don't know yet. I don't know yet. So still get the index, whatever. This is probably just like return the update as is, like it's good. And this probably should take the update itself instead of taking the one in the scope above. And we can do if this is true, then it's already good, so we just return the update. Else, we need to swap two numbers. Haskell swap numbers in list. Swap elements. Fuck, why why does it always have to be like this? Yeah, this is not fun. This is not fun. This isn't fun, my dude. Uh, and by the way, just 23 factorial is what? What the fuck is this? Factorial. It's a very large number. Okay. Just starts doing something. The brute force approach didn't seem that bad. How do I soup? This is like the simplest thing in the world in other languages. This is the simplest thing in the world in other languages. Poop, 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 poom, poop, poop, poom, poop, poop, poom. But maybe if I swap those, then the other rules won't be valid anymore as well. So maybe that's not the solution. I could just call fix update a bunch of time until it's valid and keep swapping them. But first it would be nice if I could swap them. Uh, Swap I1, I2, update. Is there a built-in swap that I'm overwriting if I do this? Yeah, and as well, I need to fix that one. Yeah. I don't know. Ik weet niet. Alright, let's just copy paste this thing. I know copy paste bad, but I am tired. Swap elements at, and let's suppose this works. Next, what do I do? So I have an update, and I need to modify it again and again. Isn't it just fold L? Where's my fold? Fold. Given a structure with elements whose type is a monoid, combine them. Is there just a normal fold? Fold L? That seems a bit better. So let's say we start with update. Can I run a function on something until a condition is true? That's what I want. Can I like map fix to update? Uh, uh, and like I want to, of course, so this is gonna generate one fixed function per rules, and I want to apply. I want to apply all of those. Like I want f. Yeah, I don't know. I don't know. And so I'm gonna apply the fixed function a bunch of time. Yeah, that's not gonna work. Haskell loop until. Is there an until? Oh, there is an until. What is until? Until P(f) yields the result of applying f until P holds. So this is the predicate, this is the mapping function. I think that's what I want. And this is in prelude. So let's do until validates rules. Well, first, how much have you done in Haskell previously? I don't know, I've done a few pet projects, a few things like puzzle like this as well, few school projects, and yeah, that's about it. I'm not an expert by any stretch of the imagination. This and whatever, I want to take like the update and apply something to it, and that I don't know, and I want to run this on the update. And so what do I want to apply again and again to the update? I want to can't I fold it? Like fold L, which will take like the fixed, the f, so the fixed function, and we start with u, and we say, and we do like this will be a map fix on rules, like so, kind of. Okay, so this will be a function, this will be fixed, and f fixed. Does that even make sense? Oh yeah, and of course this, well, this just isn't necessary. And until validates rules. Oh yeah, this takes the rules. Fuck, it's long again. Let's, I'm guessing it's an infinite loop because my thing just doesn't work. Example, One. Oh no, it does work. Oh, of course it doesn't. I'm fucking stupid. So let's not do that. It was still the permutations thing. Um, boom, 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 boom. So I should just print this map fix update on invalid updates. And this takes the rules. No, no. This one takes the rules. Like so. Doop, 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 doop. Fuck, okay, it just doesn't work. Which was to be expected. This is a bit messy and I'm actually not sure the thing of swapping the elements works. What if I only apply it to the first one? What if I do fix update this on huh, this also doesn't work, which is strange because the first one is valid. Well, why do I do a fold L? This can be until as well. So it will be. Wait, I'm for. No, okay, I just need to apply fix again and again. Map fix rules. Can I forget the until for now? And just literally run the fold. This. Which should also return like the first, let's say, iteration. Where's the U? This will be update. And so cat example 1. So this hasn't changed. Oh, it shouldn't. What the fuck is this? What is this? Oh yeah, invalid. What if I just do updates like so? So this hasn't changed. That makes sense. The second one is also valid, so it shouldn't change. Yeah. The third one is also valid, so it shouldn't change. That's correct. The fourth one should change. But it did something very weird. So why did it duplicate some numbers? Is this just not good? Left, middle. What's the... The fuck is this? What the fuck is this? Okay, let's test that the swap element at actually works. Print this, let's say 0, 2, and the list will be 1, 2, 3, 4, 5, 6. Actually, why do I do this? I can just use Haskell. Like so. So this will have swapped this guy and the fourth element. Wait, 2, 0, 1, 2, yeah? Yeah, it does seem to work. Uh, it does seem to work. Why? Why doesn't it? Why doesn't it? What if I pick a more complex case? So this guy with this guy. Yeah, that does work as well. So the swap element at I copy pasted from the internet works. So maybe my fold L thing isn't good. Let's just well, I can't copy paste that. That's stupid. Can I, instead of the fold L, can I comment this for now? Can I just do one fix? Can I do like head rules on update? Like so. Can I remove this? So cat example 1. Okay, so this time it hasn't messed it up. Yeah. Has it changed it in any way? So, wait, let's go back here. So the fourth one does not, because this guy doesn't pass. And this guy is the 95, 95, what? 97, 97 what? 97, 75. This guy. So this is the 16. 16. This is all very strange. Okay. So if I do stuff whoops. If I do stuff that passes. If I do stuff that passes, so let's say the 14, it leaves the thing as is. But if I run this, it all of a sudden messes up my thing. So what goes on in the fix function? How does it even manage to... And so this stems from this, right? If I do update and I comment this out, yeah, all of a sudden it's back. Why? How did it manage to duplicate this? That's crazy. Swap element add. And so we're gonna have 0 and 1. Okay, let me just again, this is weird. Swap element at, so 0, 1 of this guy. Yeah, it can swap them correctly. What? Oh, what if I do 1, 0? Ah, okay, 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 okay. I see. I see what is going on here. So, can I do this? Otherwise, this is gonna be this. If I greater than j, then it's gonna be swap element at ji x's. So, like so. Uh, Okay, for this copy pasting stuff from the internet is not for the faint of heart. Huh? So I do this, it's good, except now, yeah, I do the 15. And wait, if I do the 14 now, it leaves it alone. Okay, good. Now, yeah, let's keep that. Except that now I would like to put back my. Let's keep that to try stuff. Or what did I had before? No, it's not. Let's do the fold thing. That seems correct. So, and the fixed one is gonna be this, which is what I have. Okay, that's a good sign. Let's actually do this. Is this the correct thing? Yeah. Fuck, that's not it. Okay, so let's take this guy, put it here, and let's redo this. Now it's correct. Okay. Okay. And so my fixed invalid is going to be equal to this instead of this permutation thing. And then I can just print this. Okay, that's good. Oh, fuck yes. Oh. Ugh. God damn. That was painful. Alright, day 5. It actually wasn't too bad. Only 1 hour to do all this. Let's say like trying on all the permutation of the invalid updates didn't work due to time complexity being big O of n factorial is the thing before. I forgot. What is factorial notation? Fuck it. I type factorial notation and there is not the. Okay, it's after. Okay. Okay. Can I do some kind of where sum of the lm is equal to this? Yeah. And so can I do result 1 is equal to sum of middle lm valid updates? Result 2, sum fixed invalid. Result 1, result 2. Could match expectation, this. What if I do okay, isn't there like a cleaner way though? Whatever. Whatever. This is fine. Yes, let's do import data printf. Part 1. Oops. Like so. Part 2. Oh yeah, it's text printf. Okay, that works. Alright, let's delete this. And let's say that I copy pasted this from somewhere. From this. I modified it so that it supports the indices being out of order, like so. Modify it so. This. Alright, this is fine. My split thing. Do I use it? Oh yeah, I do use it. Yeah, whatever. Where's my thing? This. Let's say that it's from there. From this. Alright. Let's say something like utils. Alright. To separate what's what I think should be in the standard library from what is the actual logic. And this is all quite ugly. Um, this is all quite ugly. Actually, we could just remove this. Yeah. Um, then. This feels like it should be easy to, like this lambda, it feels like it should be easy to do. Huh, I don't know. Should be easy to replace with something. And also this lambda as well. Is there like different versions of fold that just do what I want? Fold. So I have fold L. Yes, sure. And then there is this guy, which left associative. What's the difference? So this guy takes BTAB, BTAB, BAB, BAB. I don't get it. Fold L1. A variant of fold that has no base case and thus may only be applied to non-empty structures. Yeah, that's not me. Fold map. Yeah, oh well. I'm already quite tired. I'm happy I found both solution at least. Solutions. And yeah, I think I'm gonna leave it here for now. Even though everything is a bit ugly. But oh well. I think that's not it's not the end of the world. Could I do something like a map read int this out of curiosity? Oh yeah, I can. Awesome. That's slightly better, but not by much. Not by much, unfortunately. I'm watching you struggle with delight. Well, I mean, it's the end now. The struggle has ended. It reminds me each time how hard this Haskell thing is for me. A procedural guy, it requires mental switch. Yeah, I mean, you don't have to be a procedural or functional guy. You can wear multiple hats. I think Haskell makes it more obvious when it's awesome, and also when like you want stuff like procedural. Like at some point in this, I would have loved to have just loops and arrays, you know. But in other ways, like when I was trying the permutation things, I was like, fuck, Haskell is awesome. So yeah, And yeah, I think learning Haskell really unlocks your brain, like even in the for procedural programming, whenever you have to think recursively with stuff, I think you can apply this recursive logic that you learn in Haskell in procedural programming as well to make your program cleaner or just easier. That's why I have a 500 page Haskell book next to me. Ah, following along with you. Eee. Well, I doubt that these streams are super instructive, although they are instructive when there is actually like Haskell experts in the chat. Like I've had like 2 or 3 of those in the previous stream that just correct my mistakes, and then it's actually instructive because I learn, and then since we actually clearly explain what's happening, then you learn as well. But as a book, I have learned with Learn You Haskell. This this is it's free. You can read it online. Uh, and well, I don't know why it's weirdly formatted. It's strange. Why is it? Hmm. Okay, well, the CSS is fucked, but this is actually a great book that will put in chat and that a lot of people probably already know. So yeah, that's how I learn. If you're curious, this is like a really beginner-friendly approach to Haskell. Like he takes a lot of the mathy names and so on and actually explains what's under the hood, and he shows you that it's not that far-fetched. It's just that yeah, the naming is a bit fancy, but that's it. And yeah, I think that's going to be it for today because I'm a bit tired. But yeah, I did like this day. I did not like my solution of doing a yeah of having this swap element thing. Uh, but yeah, I mean it works. Whatever, you know. Uh, but yeah, I think there is probably a much cleaner approach. But oh well. Anyway, have a nice evening or a nice morning or a nice noon, depending on where you are. And yeah, I'll see you some other time. See ya.